it is not practical to carry an extra battery pack in an electric vehicle. So for the battery pack swap, there have to be some sort of swap station. However, if you have a 300-mile range car, you're really not talking about a lot of swap stations. You just need, say, one between LA and San Francisco. And then there's a question as to whether people will even want to swap a battery pack rather than simply park their car at a highway rest stop, grab a meal or a coffee, hit the restroom, come back 20, 30 minutes, and you've recharged enough to complete the journey. I think most people will probably do that. But we wanted to preserve the optionality of a fast pack swap just in case there were people in a hurry.
Related to that, are you collaborating with Better Place at all with their notion of trying to supply swap stations and charging people for electricity rather than for the batteries?
Right, so Better Place actually got the idea of battery pack swapping from Tesla when Shah Agassi came and visited, and we told him that we were going to incorporate battery pack swapping. He was like, "Oh, good idea. Yeah, well, yeah." Not that I think it's a genius move. I mean, you have cell phones and laptops that have battery packs as well. But we're not currently working with Better Place. Yeah, and not because we don't like them or anything. It's just we don't see any sort of technical advantage or anything to working with them. That it is not obvious to us how we make the consumer experience better with Better Place. So yeah.
How much do you think it would take to do the landing that you displayed versus a bunch of parachutes? Because you have to carry the fuel weight up, and I was just curious what the offhand calculations were for that.
It's sort of on the order of about of 1,000 pounds of propellant that you need to expend to land propulsively.
Okay. How much does it take you to get into? How much do you use to get up into space?
Well, the booster, the rocket booster, is what delivers you to a parking orbit. Then you use a little bit of propellant to maneuver over to the space station. Then depart from the space station, initiate a deorbit burn, control your reentry during the descent phase. In total, there's about 3,000 pounds of propellant. So use maybe 1,000 in terms of getting to the space station and departing and deorbiting. About 1,000 on landing, and you'd have probably 1,000 spare, roughly speaking. Now, if there was something unusual happened, like you had to temporarily abort on an approach to the space station, then you might use another 500 pounds of propellant or something like that. But we will actually still have parachutes as an emergency on Dragon. So you test the engines at, say, a couple miles of altitude, make sure they're working. If they're not, then you deploy the emergency parachute, kind of like the Cirrus aircraft. Yeah, sure. Well, it's not yet in production, but on a go forward basis, most of the engineering is done. We're sort of the 90% engineering complete stage right now. The factory, we're fortunate in being able to purchase the NUMMI factory in Northern California, which was jointly owned by Toyota and GM. Although in recent years it's only been making Toyota products. It's where they made the Corolla and the Tacoma. So we were able to buy at a very good price a great factory, and thus minimize the incremental tooling cost to produce the Model S. So there's an existing paint shop, so we only have to modify a paint shop instead of building one from scratch. There's stamping machines and all sorts of things there that are helpful. The two biggest milestones this year, I think, are probably getting our stamping line operational to stamp the aluminum body panels. The Model S is actually going to be the only aluminum car made in North America. The Audi A8 and a few of the advanced German cars are aluminum, but currently there are no aluminum passenger vehicles made in the United States. Well, for me, coming from this sort of space arena, it's like, obviously you make it from aluminum. What else would you make it from? Like steel is really heavy and not great. And then the second thing is the paint shop painting a car is actually really difficult. Um, if you want to get a spectacular paint job, and we're aiming for something called which we call a piano finish, like what kind of things you see on a grand piano. So something that's noticeably better than any other car. And so that's a high bar, and particularly to do so without adding a lot of cost to the process. So I'm optimistic that we'll get, maybe not all the way there, but most of the way there. But those are the two big production milestones this year. So, wow, I got a lot of hands. Somebody way in the back of the room. Yeah. Yeah. Well, I mean, there will certainly be issues that we have to deal with, but the sort of less than 1% chance of, by less than 1%, I mean less than 1% chance of annihilation of humanity. And I mean, even if we do massively increase the CO2 concentration in the atmosphere, it is unlikely to result in the annihilation of humanity. It could kill a few hundred people, a few hundred million people, due to rising sea levels and that kind of thing, which is obviously not good. But it is not an annihilation event. But if you look at the fossil history, there have been several annihilation events. Mostly due to meteors, one kind or another, possibly some due to supervolcanoes, and some due to who knows what. But so we obviously suffer from some risk of a similar annihilation event, and also potentially a man-made thing like a supervirus, or it could be something like with the CERN Large Hadron Collider. Potentially could see a press release where the good news is we've discovered a new law of physics. The bad news is there's a small black hole that's rapidly growing. No, I think that's extremely unlikely. Clear. But we've discovered new laws of physics before. So.
Your ideas are brilliant. Congratulations.
Thanks.
Listening to you, I'm hearing sustainability and scalability maybe of some interest to you. If there were an idea out there that offered that, and probably take that idea to you.
Well, I'm not a venture capitalist. So people sometimes think I'm a venture capitalist, but actually I'm an engineer. So when I apply capital, it is to my own companies and to occasionally to the companies of close friends of mine, where I do zero due diligence, and I just basically invest on the basis that I think they're good and likely to succeed. So I'm not the guy to pitch on ideas. To be funded, because I'm not a venture capitalist. It's better to pitch a venture capitalist on that.
If it were to help your space program?
Well, I suppose if it were to help the space program, I mean, that would be quite surprised if that were the case. But it's possible. Yeah, I mean, so
Surprises are good.
surprises are good. It would look a little bit different, not that much different. My view on reusability is you have to take the first stage has to basically turn around, relight its engines, boost back to the launch pad, and land propulsively. that's tricky. Uh, it's very doable. And then the second stage is harder because second stage you're pound for pound trade-off on payload. So any mass that you add in terms of heat shield or reentry systems, it's directly subtracted from the amount that you can put into orbit. Whereas the first stage is anywhere from a 5 to 1 to 10 to 1 ratio. So you can add 10 pounds and it only takes away 1 pound of payload. And there's also a lot more you have to do with the second stage. You have to have a much more significant heat shield. You have to deorbit the stage, control it during re-entry. It's got to have some liftover drag so you can steer it back to the launch site. And then you've got to either propulsively land or perhaps use a parafoil or something like that. All those things cost mass, but that's kind of how I think it can and should be done. That's what so that basic architecture is what we're going to try to do. And the trick is to do it with just very mass efficiently, because you've only got that maybe 3.5% of mass to play with. You want to try to get at least say 2% of your lift-off mass to orbit, because that only leaves like 1.5% for everything else. So not much. Yeah, I think long term you'd see that sort of thing, and maybe even in the initial phase, it kind of depends on whether the country builds, United States builds a super heavy lift or not, like a 7.5 class vehicle. If you have a 7.5 class vehicle, you don't need to do on orbit assembly. If you have something smaller than that, then you do if you want to go to Mars. So it kind of depends on how things unfold in that direction. I think it'd be great to have a super heavy lift launch vehicle. If it's done in a typical government-driven way, I think it will not come to fruition because of massive schedule overruns and massive cost overruns. So it really depends on whether NASA decides to take a commercial approach to super heavy lift. Then there will be super heavy lift and obviate the need for on-orbit construction. And then when there's a lot of traffic between Earth and Mars, I would expect there's probably some large kind of space cruiser that's circulating between Earth and Mars, and then you just basically take a small shuttlecraft up to the space cruiser, if you will, and the space cruiser gets refueled from Earth or from Mars. But that's a long-term optimization, and it would be driven by a lot of traffic occurring between the two planets.
Quick question about, as an entrepreneur in space and with an international background, how would you characterize the relationship with federal government, U.S. federal government?
Well, I think it's generally good.
Is it a customer relationship, or is it a potential funder, or?
Well, NASA is our biggest customer for SpaceX, so they certainly are huge on the customer front. They about 40% of our launches are for NASA. They haven't. They did pay for demonstration flights, so they were sort of a quasi funder. But it was specifically for their needs. So it wasn't just sort of, here's some money, do what you want. It's like, we have a specific need, we'll pay you as you demonstrate milestones in that direction. In the case of Tesla, we were fortunate enough to receive a government loan last year, which was unrelated to the bailout. Unfortunately, it was announced right around the time of the bailouts, but so people sort of assumed it was somehow a bailout. But the loan that we received was actually part of a program that was initiated in 2007 in boom times, and one of the requirements of that loan program was that you had to be a viable entity in your own right and provide 20 to 30% of private capital as a matching contribution, which therefore excluded, for example, GM and Chrysler, who were bankrupt. Um, so Ford, Nissan, and Tesla did receive essentially lines of credit and which are specifically related, in our case, specifically related to the engineering and production costs of the Model S. So it's certainly helpful from a capital dilution standpoint. And then if we repay the loan early, then there's no capital dilution. But if we don't repay the loan early, then the U.S. government gets a bunch of stock warrants in Tesla. So I think it's a pretty sort of smart. I mean, in the grand scheme of things, of the various government deals that are done, this is, I think, one of the smarter ones. Yeah, I think, I mean, there will be many sources of electricity that are sustainable. There's obviously, wind, geothermal, hydro, and but my personal view is that solar power will be we will generate more electricity from solar than from any other single source. It may not be a majority, but I expect at least plurality from solar power. And that will be a combination of photovoltaics at the point of use, roofs of houses and businesses, which is also good from the standpoint of not requiring additional power lines. And then at the power plant level, I think we'll see a lot of solar thermal power generation, where you're essentially just using the sun to heat a working fluid and then generate steam and power turbine. There are a bunch of those projects that are going to come online in California and a few other places in the United States soon. And if you think of solar power, I mean, if you think of sort of beyond humanity's need for electricity, the Earth is almost entirely solar powered. The whole weather system is solar powered. Almost the entire weather system is solar powered. A little bit of it is from Earth rotation, but all precipitation is solar powered. The only reason we're not a frozen dark ice ball at 4 degrees Kelvin is because of the sun. The whole ecosystem is solar powered. I mean, plants are essentially a solar powered chemical reaction. So we're just talking about replacing this itty bitty thing called electricity and having that also be solar powered. Sure.
So I'm a Tesla stockholder.
Oh.
And because I thought you had a great idea and you already gave class.
Thanks.
But you've been so successful that you've now gotten major car manufacturers in the game.
That was the intent. That was the whole idea.
Yeah. But, is Tesla going to be a small black hole? I mean, are we going to have a problem with sustainability of Tesla because of the large manufacturers?
No, I don't think so. Like I said, the whole purpose of Tesla was to draw the rest of the car industry into electric cars. So the more electric car programs I see being announced, the happier I am. The success of Tesla as a company financially is going to be a function of the quality of products that we produce. So we have to make better cars than, say, GM and Chrysler. I don't see that as a huge challenge. So, no, I mean, the sad thing is that generally in the United States, if people can afford an expensive car, they do not buy an American car. And I think in the 60s, the U.S. made great cars, and before that made great cars, but then something happened in the 70s. I don't know what happened. It was a lot of bad things. Architecture went to hell, fashion was questionable. And our cars turned to shit. So I think actually, there's a friend of mine summarized the Tesla strategies to, in the long term, is to make cars that don't suck. So, so I think we'll be okay. And there's some vindication in that Toyota, which is the largest car company in the world and the leader in hybrids, is an investor and partner with Tesla. And if it was easy, they would simply do it themselves and not bother to partner with us. Daimler was the inventor of the internal combustion engine car, the maker of Mercedes and Smart. And again, they would not ask us to be a supplier to them, nor would they be an investor in Tesla if they thought it was a simple matter to replicate what we're doing. Sure. No. There's aluminum is great. The Audi A8, for example, is an aluminum car. All the airplanes that you fly are mostly aluminum, and aluminum is harder to work with in terms of bonding and joining. Um, it's harder to weld than steel, for example. So it is technologically more difficult to work with, but it is a superior metal for anything where weight is important. That's why planes are not made of steel. In fact, the Model S, our design target is to meet a 5-star crash rating by 2012 standards, which are higher than a car that's 5-star by 2010 standards is only a 3-star by 2012 standards. So we have a very high bar that we're aiming for from a safety standpoint. And obviously, I'll be driving the car. My friends will be driving the car. Our beloved shareholders will be driving the car. So safety is extremely important. If I don't think there will be a safer car on the road. Oh, sorry. So the price, it's kind of like a 5 Series BMW. So depending upon configuration, it would vary from about $50,000 to $100,000. Yeah. Sure. Mm-hmm. Well, I generally think that that there's been a bit too much outsourcing in general, both outsourcing out of California, outsourcing out of the United States. Business sometimes tends to be a little fatty. It's sort of like there was for a very long time a very strong outsourcing fad, and but I don't think people really looked at the fundamentals in a lot of cases when they outsourced, and particularly when the technology is evolving rapidly. I think it's important to have a tight iteration loop between engineering and production. So as soon as you've designed something, you can bring it to production right away, and you can get the engineers can go on the floor and see the mistakes that they've made. The production people can talk to the engineers and say, here's some good ideas, and so you can evolve the product and achieve get to a better design solution faster. I think this is an important thing that's often overlooked. At SpaceX, our rockets are lower cost than the Chinese, Indians, or anyone else, and that's before reusability is taken into account. And I think it's because of that tight iteration loop. And in the case of Tesla, the Fremont plant, the NUMMI plant, they until April 1st of last year, they made the Corolla there, which is a $17,000 car. So if it was fundamentally too expensive to operate in California, how could they make a $17,000 car? We in California, I think we do need to be cautious about adding more and more costs to living here. I do think we're close to we're on a cusp of a tipping point. If the taxes start getting much higher than they are. If they can take California, the marginal tax rate is 11%. You could go to the state of Washington and pay 0%. So it is an expensive place to live. I like living in California, so I'm here. But I know many people who have moved out because the taxes are too high, or the workman's comp and other costs are too high. California does I think tend to overregulate a little bit. So I think generally California is going to have a really tough thing to do, which is it's got to cut the cost of what it spends at the state level, and maybe even reduce the taxes a little bit to be competitive with other states, and deregulate. Those are the things that can be done to increase employment in California. Politically, these are difficult things to do. And I'm not entirely sure how California gets out of this bind. It might have to be a proposition or something, because the legislature seems unable to arrive at anything sensible. Sure, sorry. Yeah. No materials limitations in space. Silicon, don't worry about silicon from a limitation standpoint. There's lots of silicon. Copper is probably okay too. There's quite a lot of copper in the world. For battery packs, one of the challenges we had was cobalt. Actually, cobalt is only available in a few places in the world. It's quite expensive, and the biggest source is the Congo, which it tends to vary in its political stability. So that's why going to the Model S, we changed the chemistry to require only about a quarter as much cobalt, and thus reduce the cost of the battery pack, and actually also increase the energy of the pack. If you're going to worry about any material shortages, maybe some rare earth elements are maybe a concern. China has a huge concentration of rare earth elements, which are used in permanent magnet motors. To avoid that issue, well, actually, there are other reasons for it as well, but Tesla has an electric motor design that doesn't use any rare earth elements. I think we're generally okay on the commodities front. I wouldn't worry too much about it, except for the non reusable commodities like oil and that kind of thing. So by the way, oil prices are going to go way up, in case anybody's wondering. I want to make sure it's really okay. The back there. I'm not too worried about recharging stations. The great thing about electricity is it's really ubiquitous. I mean, there are more power outlets than access to any other kind of energy by orders of magnitude. In the case of Tesla and most of the new electric cars that are coming out, the charger is built into the car, so you can plug it in almost anywhere. If you want to charge fast, you're going to need a high power outlet. But what we're seeing with the use of the Tesla Roadster is almost all charging occurs at home. Like 90% plus. Now it is important that you have a range that is reasonable. If you've got sort of a really low range, like say 50 miles range, then well you can't do a lot of round trips. I mean, 25 miles is your max, and you're being pretty sporting if you do that. So as you reduce the range, you start to require a lot of charging stations. But as you increase the range, the number of charging stations you need tends to drop with the square of the range. So you've got sort of a circle that you can travel in, and so the bigger that circle is, the fewer recharging stations you need. And So for something like the Tesla Roadster, you only need one charging station between LA and San Francisco. It's a 400-mile trip. You get 250 miles of range, so you just need one charge station. But if you had a 50-mile range, you'd need probably 10 charging stations. 8 to 10 charging stations. So I think you'll really only see a lot of use of charging stations, at least as far as Tesla cars are concerned, on the interstates. So when you're making really long distance trips, that kind of thing. But otherwise, not.
I was told some years ago, your comment about being fundamentally engineer reminded me of SpaceX.
Yeah. Yes. Sure. So in the case of SpaceX, unfortunately, the supply chain in the rocket business is very shallow. Very often there is only one supplier, and it's a very expensive supplier, and they're really not designed for reusability. So you're screwed if you don't make it yourself, basically, for the most part, And so that's led to SpaceX being sort of maybe 70 to 80% of the rocket being built in-house literally from raw material. And I guess another way to look at it is, to the degree that you inherit the legacy components, you inherit the legacy cost structure and limitations. So it is not from any sort of religious bias towards insourcing, but rather because on the fundamentals we were driven to do that. In Tesla, in the case of Tesla, the automotive supply chain is much better. It's much more competitive. There are many suppliers for any given component, and so maybe 40 to 50% of the Tesla Model S is insourced. Yeah, that's sure. You mean use parts that are in a rocket in something else that they're doing? Not yet. There've been a few inquiries about using our engines in some other programs, which we've responded to, and it could happen that our engines are used in some other government programs. We do, yeah. Well, just distinguish between heavy lift and super heavy lift, because there are rockets that, like our Falcon 9 Heavy, and there's the Delta IV Heavy, and these are sort of on the order of, in the case of Delta IV Heavy, it's about maybe 25 tons to orbit. In the case of Falcon 9 Heavy, it's maybe 35 tons to orbit. But compared to the Saturn V, which was over 100 tons to orbit, it's there's a pretty big difference there. So generally we call it sort of super heavy in the 100-ton plus class. SpaceX would really like to build a super heavy, and I think we could do it for a small fraction of what people think it would cost. Actually, I've gone on record as saying I think we could do a super heavy for development for on the order of $2.5 billion. Prior other estimates sort of are about 10 times that, and the super heavy that I'm just alluding to would have about 160 ton to orbit capability, so way more than a Saturn V. In fact, I've even gone as far as to say that I will guarantee that personally, and stake everything on SpaceX that it will happen. So, we'll see. There are strong political forces that don't want us to do that. So I'm trying to eliminate any argument that they could have for not not at least allocating a small portion of the super heavy lift funding to give us a shot at making it work. They can take all the rest of the super heavy lift funding and apply it to the traditional way. We will take the sort of 10 to 20% of that number on a fixed milestone basis. So if we don't achieve the milestones, we don't get paid, and I will personally guarantee it. So, if we don't achieve the milestones, then that money can then be applied to the other programs. So it is a no-lose proposition. But logic does not always prevail. Yeah. Right. Sure. Yeah. Yeah. Mhm. Yeah. Yeah. I think Tesla will be okay. I would say on balance the federal government has been helpful to Tesla, and yeah. So in the space arena, well, man, this is a complicated situation. But the out of necessity, NASA has out of budget necessity, NASA has gone commercial as far as cargo transport is concerned. And then last year, President Obama said, well, we should also outsource astronaut transport to commercial entities. If we can fly in Boeing airliners and Airbus airliners and feel good about that, then why can't our spacecraft be built by commercial entities too? But there was a battle royale last year against that, which won by a 3% margin in the House of Representatives. It was a hairy battle, but it is moving in that direction. It's somewhat unavoidable. I mean, it's going to be that or nothing. So I think it's going to be that. Yeah. So overall, I'm pretty optimistic about it. I probably worry slightly more about in the space arena about some of the big government contractors. They would definitely like to see SpaceX die. I'm sure I'm being tortured in effigy right now. You know how when you see a movie and like there's the bad corporation in the movie, that's like the big defense contractor. So those are a competition in a lot of cases. So yeah. Okay, I'll take a couple more questions and go ahead.
Hi, I'm actually from NASA, from Washington, D.C. We have a huge fan base within NASA.
Great. I'm a huge fan of NASA.
We love everything that you're doing. You tell us about the way you're doing it.
Yep.
And we're probably, I think the people, most of the people I work with, we're quite embarrassed sometimes about how much money the contractors charge for something. You had a story that you just tell about a politician meeting that you went to one of these contractors meetings,
Mhm.
and they said that they were charging so much that you didn't know.
Yeah, that's happened many times. Actually, um, we didn't start out insourcing, 70-80% of our hardware. Initially, we thought, well, we'll try to do as little as possible, but then over time, we just insourced more and more out of necessity. And we found many times that we would sign a deal for supply of a component, and then that supplier would find a reason to triple the price. So basically, as soon as they thought we didn't have any way out, then they would start with the conclusion, which is triple the price, and insert reasoning. That's happened several times, and then we've insourced the part to this price. But often with a lot of grief. Yeah, I'm very pleased with how things are now, but it was very, very hairy for a couple of years there in late 2007 through, say, first half of 2009. We came close to not making it. So. All right, last question. Is there somebody who I've been ignoring for a long time? Okay, all right, go ahead. Sorry.
Thank you very much.
You're welcome.
I'm guessing you hear comparison between yourself and Richard Branson sometimes. And I'm wondering if your relationship with him is cooperative or competitive or both.
Richard who? Actually, I'm a friend. I mean, Richard Branson's is a friend of mine. He's a very affable guy. He's not a technologist. So he's sort of. His strength is brand and marketing and that kind of thing. He's very good at that. I think going into the rocket game is tricky because it is very much a technology problem. So I think he's gonna encounter some challenges there. Also, what Virgin Galactic is doing is a suborbital flight, which is only about 1.5% of the energy that you need to get to orbit. So it is a much simpler problem. It's basically you shoot up to about sort of 60 to 70 miles, and then you fall down. That's essentially what they're doing. It's like the world's best roller coaster ride. So it's like a really fun trip, but it's not a technology path that would ultimately take us off to other planets and that kind of thing. But I think for a lot of people, there's not a clear distinction between getting to space and getting to orbit. And space is somewhat of a loose definition. It's kind of where does the atmosphere get thin, and you can sort of define how thin is thin. It's pretty darn thin at 60 miles altitude, but you can't have a satellite up there because the orbit would decay very quickly and it would re-enter. And going up and staying up is actually about how fast you're zooming around the Earth. It takes much more energy to do that sort of zooming around the Earth bit than it is to get the altitude. In fact, the only reason you need altitude at all is to get out of atmospheric drag. If Earth had no atmosphere, you could be orbiting Earth at like an inch above the ground. So to get to orbit, you need at least to go about 25 times the speed of sound for Earth. And the energy required scales with the square of the velocity, so that's say 625 units of energy. To do a suborbital flight, such as what Virgin Galactic is talking about, you need maybe about Mach 3, which is 9 units of energy. So it's a pretty huge difference. And then if you want to re-enter, you have to burn off 625 units of energy, or burn off 9 units of energy. So it's a giant difference. So all right, well, thank you.